Hi, hello and welcome to BK's Tech Stack. I am BK, your AI tech bot. Today we are going to learn about data manipulation with Pandas. Let's dive in.
Pandas is built around three primary data structures: series, DataFrame, and panel. A series is a one-dimensional array-like object containing a sequence of values and an associated array of data labels, called its index. The data frame is the most commonly used structure. It represents a tabular, spreadsheet-like data structure containing an ordered collection of columns, each of which can be a different value type. For higher dimensional data, Pandas offers the panel, a 3D container, though data frames with hierarchical indexing are often preferred. Understanding the dimensionality and axis labels, axis 0 for rows and axis 1 for columns, is fundamental to mastering Pandas. A series is the building block of Pandas. It can be instantiated from various inputs, including Python lists, NumPy arrays, dictionaries, or scalar values. When creating a series, you can define an explicit index. Otherwise, a default integer index from 0 to n-1 is generated. One of the most powerful features of a series is vectorization, allowing you to perform mathematical operations on the entire array without writing loops. Crucially, when performing operations between two series, Pandas automatically aligns the data based on the index labels. If a label is present in one series but not the other, the result will be marked as NaN, ensuring data integrity is maintained. The data frame is the workhorse of Pandas. It is essentially a collection of series objects that share the same index. You can construct a data frame in numerous ways, providing flexibility for different data sources. A common method is passing a dictionary of equal-length lists, where keys become column headers and values become the rows. Alternatively, a list of dictionaries can be used, where each dictionary represents a row. Data frames support heterogeneous data, meaning one column can hold integers while another holds strings. This structure allows for complex data manipulation that mimics the functionality of SQL tables or Excel spreadsheets, but with the programmatic power of Python.
Real-world data is rarely clean. Missing values, represented as NaN in Pandas, can arise from system errors, data integration issues, or user omission. Pandas provides robust tools to handle this. You can choose to exclude missing data entirely using drop_NA, which removes any row or column containing a null value. Alternatively, you can impute missing data using fill_NA, replacing NaNs with a static value like 0, or a calculated metric like the mean or median of the column. Advanced filling methods like forward fill propagate the last valid observation forward, which is particularly useful in time series data. Proper handling of missing values is essential to prevent skewed analysis.
Pandas excels at complex data operations. The group by method is a powerful tool that implements the split, apply, combine paradigm, allowing you to group data by one or more keys, apply a function like sum or mean, and combine the results. Sorting is handled via sort values, giving you control over the order of your analysis. For custom transformations, apply map allows you to map a function to every element in a data frame. You can also perform statistical analysis directly on data frames to calculate standard deviations or correlations. These operations allow for deep analytical insights and data standardization, preparing your dataset for machine learning models. Pandas is not an isolated tool. It connects seamlessly with the broader data ecosystem. It supports reading and writing to a vast array of file formats, including CSV, Excel, JSON, and HDF5. Crucially, Pandas integrates directly with SQL databases. Using libraries like SQLite 3 or SQL Alchemy, you can execute SQL queries and load the results directly into a data frame using Read SQL. Conversely, processed data frames can be written back to a database using ToSQL. This interoperability makes Pandas a central hub for data pipelines, allowing you to ingest raw data, process it in memory, and export the refined results to permanent storage.